Hello guys, welcome to a brand new Dev Coffee Talk. This is a place where we talk and discuss about software topics and software concerns. So in today's episode, I want to talk about the premature optimization. Have you ever heard about this concept? Premature optimization. What is it? So this might not be well known to you guys, but trust me, there are a bunch of authors of like software development book and best practices book that all of them refer to the concept of premature optimization as an anti-pattern and as something that we should avoid doing. So let's talk about it. Premature optimization. So as the name may suggest, it basically refers to the idea of optimizing for performance at very early stages in the project and in the software development life cycle, we could say. So what is premature optimization and why is it an anti-pattern? So premature optimization. So when we often, want to optimize, when we want to make something better, we want to improve some piece of code, some classes, some algorithms that we are using. When we talk about like performance optimization or performance tuning, what we really want to do is mostly reduces to two things. So improve memory usage by using an alternative algorithm or a data structure that happens to use much less memory than what we are already using. So that will be a space performance optimization because we are improving the way we use memory, or make things faster. So speed up things, speed up the algorithm, and this often happens by reducing the time complexity of our algorithms. So these are performance optimizations, and there's a huge range of technologies and techniques and approaches and tools and practices that we can use to accomplish these goals. Now, here's the problem. Often, developers sit down when they are writing some code, some classes. They come up with a good object-oriented programming design. They think of modules, components, functions, objects if they're doing OOP, and they want to optimize right there, right? So like the very first time they sit down and start writing some code, they immediately want to optimize. So what very well-known books and authors criticize about performance optimizations, or I should say like performance optimizations at very early stages in a project, is that every time you want to optimize your code for either memory usage optimizations or to make it faster, you're adding extra complexity to the code, right? So you are making things much more complex because often optimizations come with low-level details like specific technologies and specific solutions, specific vendors, specific algorithms or data structures that make the code much more complex, hence less readable, because you believe that is going to solve a potential problem, a potential optimization issue. You base all those decisions just in your intuition, right? So you have not measured how much does it take for your software to run how much memory is it taking when it's running. You have not measured anything, hence you don't have any real ideas that everything you want to do, everything you're doing, those performance optimizations are really needed, right? So that is wrong. That is the anti-pattern. You're sacrificing software understandability, readability. You are making things much more complex than they were, just because you think there could be some memory leaks or things could be slower, but you haven't measured a piece of your code. That is what we should avoid, right? So making decisions, making like these sort of decisions just because we have this developer's intuition, right? So we think, okay, this piece of code, this line of code, it's going to produce a memory leak, and we just move on and make some tweaks, make the code much less readable, much more complex. We start doing some coupling with certain caching packages or modules or strange data structures and vendors, and we actually don't have any idea that we are solving an issue. We actually don't. We are not even sure there's an issue to start. So this all comes from premature optimization. That is basically we want to optimize what we haven't even built yet, right? So the best approach, according to Martin Fowler and all these authors that criticize premature optimization, they propose that you should first make the code readable. That is where you should put your effort at first. Make it readable, make it easy to understand, easy to follow, make it explicit, right? So stick to programming practices that help you achieve that. And then once you have achieved that, once you have a clear piece of code, you have a clear structure of components, modules, functions, or objects that interact to accomplish a goal, and everything is easy to understand, is explicit, it's closely coupled. So once you have achieved all of that, performance optimization, it's going to be much easier, because making those changes is going to take less time, because you have a clear picture of where you need to make the changes. And also you should base those changes on measures. So you should measure first, optimize later, right? So that every optimization that you make in your code, you are always sure that it's going to have an impact, right? It's going to make things better. It's going to make things faster, right? Or lighter for memory. So that is about premature optimization, right? So first, focus on your solution. Whatever you're building, it has to be clear, it has to be understandable, easy to maintain. So we want it to be easy to make changes, right? Because this is not for you, right? So you shouldn't think, okay, I'm building this thing but I'm gonna be the only one working on this thing, right? So you don't have to think that way, right? So you have to switch your mindset. You should think on the future developers and the future staff who is going to be working on your feature, on your piece of code, and understanding that code and making changes to that code should be an easy job for them. So first, put your effort on understandability, right? Then measure. If you ever have you are suspecting everything is not working as expected, then you should measure right? So measure whatever spot in the code you are suspicious about, and then make the changes to make it faster or to make it lighter. But measure first. Do not trust your intuition with no measuring. And this is hard to believe for developers. It's hard to follow, right? So not trusting your intuition because of your experience or because of your background. But believe me, some lines of code might seem to be like underperforming, but often that is not the case, where the things that we think are underperforming often are not. So, and this is crazy, right? And it has to do with how the compiler translate that code into like machine code and all that like low level details. So some examples of primitive optimization. I've seen it many times in different like teams that I have worked on, that often developers are like resentful. They are reluctant. They don't want to use object-oriented programming, for example, because they think that's going to be slow. That's going to introduce objects and things that have to be loaded into memory, and it's going to take a lot of time. So it introduces a delay, and they avoid using object-oriented programming because of that. Or they avoid splitting a long function into several smaller ones because of the same reasons. They think, okay, this is going to consume much more memory because of the call stack or whatsoever. So they avoid using like smaller reusable functions instead. And of course, this is nothing true, right? So at the end of the day, the compiler or of whatever programming language you might want to pick is going to run some low-level performance optimizations. It's going to join your functions into a whole bunch of ones and zeros, and the same applies for the classes and the objects that you use. And also there's a garbage collector, so everything is actually taken care of. So instead, you're doing your code much cleaner, much easier to understand and to follow. Also, something I've seen at some point was, reutilizing the very same variable and naming it with some fancy names such as temp, like for temporary, or aux from auxiliary, and then use the same variable again and again. And here the thought was kind of like the same, right? So why would I want to use a single variable for each thing that I want to do in my code? I'm better off reutilizing the very same variable, because at the end of the day, my program is going to take less. It's going to take up less memory. So this is incorrect, right? So you're putting your effort in the wrong place. It's not big deal. It's not real impact, unless it is like specific use cases and specific scenarios. So for example, if you're working in a software that has to run under specific restrictions for hardware, like embedded software, for example, then it's a different scenario, right? Performance is important there. Put your effort, put your focus in making your code understandable and readable, and then optimizing for performance is going to be much better. And if not, anyways, developers are going to be grateful because your code is cleaner and it's easier to understand and it's explicit, and making changes to it is an easy task, an easy job. So everything is going to be much better for your software, your project, your team, and hopefully your company. And that is all for today's session, guys. So I hope you really enjoyed this one, and I'm coming back with more topics for discussion. So if you really like this video, hit the like and subscribe buttons, and stay connected for more content like this. So I really appreciate you listening and watching this video, and thanks, and have a nice week. See you later.